So today we're going to talk about solving compound inequalities. When we talk about compound inequalities, what we're thinking about is it's an inequality that consists of two inequalities connected by an or statement, and with union or with intersection. Okay? In general, each part can be solved separately, but in the end you have to tie back both answers together appropriately. Okay, so we can split the inequalities up, solve them separately, and then put the answer back together. So let's look at some examples. In example 1, we're going to look at solving 5x plus 7 is greater than 27 and 2x minus 8 is less than 4 for x. So that and statement means both. Okay, so I split the two inequalities up and then I solve them like I would any other equality. This is two steps, so I subtract 7 from both sides, divide each side by 5, and I'm left with x is greater than 4. No need to change the inequality sign because the coefficient value is positive. On the second inequality, 2x minus 8 is less than 4. I add 8 to both sides, and I'm left with 2x is less than 12. Divide each side by 2, and I get x is less than 6. So I've solved them each separately, the inequalities. Now bring them back together for the final answer. X is greater than 4 and x is less than 6. Interval notation would be written like this. In our second example, we're going to look at solving using an OR statement. Solve 3 times the quantity x plus 1, which is less than or equal to negative 6, or 5x minus 14 is greater than or equal to 21. All joking aside, you can't pick just one or the other. You have to solve both of them. So just because it's an OR statement, we've had students before will tell me, well, I thought I got to pick. It's an OR statement, one or the other. You got to do both. Okay? So I split the inequalities up, and again I solve them. First here I distribute 3 groups of x plus 1, 3 times x, 3 times 1 is 3, less than or equal to negative 6. I subtract 3 from both sides, and I'm left with 3x is less than or equal to negative 9. So be aware, notice how the coefficient here is positive, so the inequality won't change. Some mistakes happen when kids see this negative number and they switch the sign. You only have to switch the sign when you divide or multiply by a negative number. In this case, we're dividing by 3, which is positive. The inequality stays, so it's x is less than or equal to negative 3. We'll leave the OR statement. Here's 5x minus 14 equals 21. Okay, so 5x is less or greater than or equal to 35. So that means x is greater than or equal to 7. So putting these answers back together, you have x is less than or equal to negative 3, or x is greater than or equal to 7. So here is the interval notation from negative infinity to negative 3. You can include negative 3 so you have a bracket in union with 7 to infinity with the bracket. In example 3, we're going to solve negative 5 is less than or equal to 4x minus 3, less than or equal to 5 for x. Now this is how we commonly write our compound inequalities. This is an AND statement. There's 3 parts. One, the left side of the inequality, the middle of the inequality, and the right side of that inequality. So there's 3 parts. You're going to solve that like you would an equation, but you have to perform the operations to all 3 parts. So you're not just adding 3 to 2 sides. 3 gets added to all 3 parts. So I start in the middle, and I try to solve for x. So I add 3 to each side. I get negative 2 is less than or equal to 4x, and that's less than or equal to 8. To get x by itself, I divide everything by 4. That's a positive number, so inequality stays the same. And I get negative 1/2 is less than or equal to x, which is less than or equal to 2. And there is your interval notation with that. So this is how most of the time you're going to see a compound inequality, especially when the AND statement all together put into one single statement there. You're not most of the time going to see it like you did in example 1 where you had solve this inequality and the second inequality. They'll put it like, the text will put it like this. Okay, in example 4, our last example, we're going to solve the inequalities here, and we're going to look at the and statement here, so one and the other. So 2x minus 1 is less than 3, 6x minus 5 is greater than 19. Solved separately, I get x is less than 2, x is greater than 6. So, add 1 to both sides, divide by 2, and add 5 here, and divide by 6. But the problem is that if you think about picking an x value that's less than 2 and greater than 6, it's going to be very difficult. It's not possible. So there's no number that is both less than 2 and greater than 6. So this is not possible. There is no solution to this inequality. No x value would work.